Welcome to the session. My name is Mercy Orangi. I lead developer relations activities for Andela in Africa. And today for our online technical workshop, we are hosting Dan Putman. He's the solutions engineer at Codacy. So Dan, as you put up your screen, I'd love to just go ahead and read out your bio. So Dan is joining us today. He has spent over 13 years in the software industry and still wakes up every day daydreaming of new products to bring to life. So Dan started out as a developer for an agile software firm called Menlo Innovations before moving on to new challenges and titles at Pillar Technology. And then after many years there, he moved on to co-found a renewable energy company before funding himself as a solutions engineer at Codacy, which is his current home. So Dan tells us that when he's not working with his clients or his lovely teammates, you'll actually find him with his family in North Carolina or hiking somewhere deep in a US national park, which is amazing. So as I transition to you, Dan, just tell us as you do your brief intro as well and share your screen, what probably has been the most challenging hike that you have been to and probably how many hours long?
Oh, wow. So I actually, this is an easy one for me. I've been to hikes in the mountains, the Rocky Mountains, some tall mountains, but the hardest one was actually a really small one in Acadia National Park in Maine here in the US. Beautiful area, but we had our 2-year-old daughter with us and we were going for the easy hike, took the wrong turn and ended up clambering over rocks and stuff with a 2-year-old and nothing raises the stakes like having a 2-year-old on the side of a mountain.
Yeah, true. All right, fantastic. And hopefully, that always gives you motivation even as you come to work. We're happy to have you here and all the best.
Terrific. Let me share my screen. And so a couple of ground, ideas around how I operate, what we're going to do today. I'm going to spend about it's 8:10 now here, my local time. Got about 50 minutes. I'm going to spend around 30 to 40 minutes talking. I really want questions. We're going to stop a few times as we go to field any questions you might have in the chat. And I really think these kind of technical discussions are best done with interaction, with answering your questions, because I've got thoughts, but we're really here for you guys. So please send them in. Beyond that, we're going to talk, I'm going to show you kind of what I think about code reviews, where I believe the value is, and then some small steps to get there. And we're going to spend a big chunk of time on the tool set that I think is best. There's a couple of options. Obviously, I work for Codacy, so we're gonna use Codacy. That's what I'm most familiar with. But I will say there are competitors. There's good other products out there. Please do your research. Don't take my word for it. Do your research. And then last thing is that I'm not a big believer in slides. I want you guys looking at code. I want you seeing links to sites I've used in the past, as opposed to just looking at my summary. So we're going to do that. We're going to be looking at a screen a lot of the times at code, at GitHub. And then I'll be posting links into the chat that you can look at on your own. If you'd like to be following along or hacking a little bit or looking at some of these resources, please feel free. I think the quicker you guys get your hands dirty, the quicker everyone starts thinking and getting creative, the quicker you're going to pick up and start thinking about how you can apply this in your work. So with all that said, what do I mean by code review? I'm assuming we've got a broad spectrum of folks here with different experiences and different thoughts. So for code review, I'm really just talking about having someone review what you've written. They might be for a number of reasons. Probably you're looking at your code quality, structure of your code, the functionality of your code, potentially looking for bugs and your test coverage. Do you have good tests? Are they written well? Are they understandable? Those kinds of things are what we're looking for in code review. Now, traditionally, back in the past, when I started my career, those were all done manually. You would literally sit down with someone side by side in your office. You pull up your code and you say, here's what changed. Here's what I did. What do you think? Right? And you go through line by line and literally point out miss comma, miss semicolon. That's not formatted the way we say we want to format it. That's very labor intensive, as you can imagine. So can we get better? Can we get more efficient? Well, we certainly can, but first we need to make sure that we understand the value so that we don't lose that value in pursuit of efficiency. The worst thing we could do would be to try and get faster and then miss things, all of a sudden introduce bugs. So I'm going to post this, and this is what I love about this article and this webpage is it's from 1991. We've been talking about code review and reducing bugs and the cost of maintenance since the beginning of software. Literally, since there was software, there have been bugs. There has been code review. So they say here an hour of inspection saves 30 hours of maintenance. I've heard that. I've heard that bugs cost 100 times what it cost. Bugs cost 100 times the what it takes to create that software. So if it took me an hour to build something, to build a function, it's going to take me 100 hours to potentially fix a bug or the cost of that bug in production, lost revenue, things like that. So that's pretty serious. We need to be doing code review. We need to be checking ourselves and making sure we reduce defects as much as possible in production. So if we're trying to do that, what are our tools, right? Well, in GitHub, let's go have a look at, one moment. Let's see, I pulled up GitHub here because a lot of tools these days have the ability to do code review built into them. So be it GitHub, be it Bitbucket, be it whatever you use, SDN. There's tools you can, if you're still using that, or Perforce, you can probably integrate with a third-party tool like a Crucible from Atlassian. But they all let you do the same thing. They let you comment on code. They show you what your changes are. You can see here in GitHub, this is a pull request. You can see how many commits were made and what they were. You can see what files have been changed, right? You're probably, a lot of you are familiar with this. And then you've got the conversation about, hey, what were people trying to do? What are some of the things they believe people should fix or change in their code? This is a pretty typical thing, but this is all manual, right? So where can we go from here, right? We've spent hours of time probably looking at this code, telling people what's wrong with it. Some of that time's valuable, some's not. How can we do better? Well, at a minimum, I would say, is we need to stop looking at the small stuff. Like I mentioned earlier, the comments, the semicolons, the formatting, those things really aren't incredibly valuable. There's value. We want to make sure as a team that we're not arguing about these things, that we're all on the same page, that we can look at code and understand it quickly, not get thrown off by a missing format, or that person chains differently than I do, change their functions differently than I do. We should all be on the same page. But that said, it's super time consuming to do so manually. So that's where linting comes in. I'm sure a lot of you have heard of linting. I hope all of you, hope 100%, but we're going to cover it real quickly. That's really the bare minimum, I believe, to starting your automated code review journey. So let's take a quick peek at what that means. So let's go ahead and hop over to terminal here. I have a simple project here. I cloned it. It's a calculator written in React. And I've done it just for just to give us an example of what a project looks like when you lint. So here I pulled this down fresh, and I'm sure a lot of you are familiar with ESLint, but we're going to go ahead and run this. And here's what we're hoping to see. At a minimum, we need a tool to be telling us, hey, here's what's wrong. You've created this team agreement around what you want your code to look like, and here's where that agreement has been missed. That's where it's been dropped. So that's, if we're looking at this, I can now have a conversation with, either my peer or with someone working under me, if I'm a tech lead, around, hey, we agreed in our tests that we were going to change our imports, right? The chai really needs to occur before calculate, right? Or I took out the double quotes, but a big one is double versus single quote, and especially in JavaScript where you put your semicolons. You can just take care of that, and it'll show up in here, and the developer will say, "Oh, yeah, I missed that. I didn't have to hunt for it. I know it's gonna be caught," and then it's an easy fix. So this is running locally, obviously. What are the problems with running my checks locally? Well, obviously it's great for the developer because they can see what has occurred. They can see before they check it in, before they push to the server, what they need to fix, and that saves a lot of back and forth. So as long as they're self-checking, that's great. Like I said, as long as they're self-checking themselves. There's the constant thing. I'm sure you're all on mute, but I'm sure people are going to sigh or laugh at this, but where it works on my machine is the deadliest phrase in software development. And no matter how experienced you get, it will still come up. No matter how good your team is, it will still come up. So we need to shift away from that and get away from that sense of it works on my machine, or possibly having different versions of linting, having different versions of plugins could affect this. Let's all get on the same page. So how do we do that? Well, to do that, we're going to put our work either on a central server or in the cloud, and do something. CI/CD is what you're probably typically used to. I talk about it in a broader sense, which is a single source of truth. You really want to aim for a single source of truth. When your team doesn't want to argue about things one way or another, say this, we're all going to work off of this copy, be it a build, be it a separate tool. So in this case, a simple way to accomplish that is with, where is my calculator? There we go. So a simple way to accomplish that with GitHub is with actions. If you're unfamiliar with GitHub Actions, it essentially is a cloud, scripting platform that functions primarily as a CI CD tool for people. It's relatively new, but I really like it being built in here to GitHub. Some alternatives, I'm sure you've probably heard of Jenkins. You've probably heard of Circle CI. Oh, I see someone saying they can't see anything. Are people able to see my screen, see a browser right now? Mercy, could you confirm that?
That was when you're on your terminal, but now we can see.
Okay, let me double check here, make sure. But could you see the terminal when I was there?
That was what was not clear.
Okay. Well, if it happens again, please let me know. Mercy, I'll let you double check me. But let's go ahead and push forward, and we'll fix that if it comes up again. So what we're looking at here, like I was saying, you got other tools, Travis, Circle CI, Jenkins. We're going to operate here in GitHub Actions for the time being. But you take what you've built locally, and you push it up to a place where I can see here, it's exactly the same thing, but now it's off of everyone else's machines, right? This environment is going to be the same every single time it runs. It doesn't matter if you're on Mac, Linux, Windows locally, it's going to be running on GitHub here, and you can expect pretty consistent behavior. So the added benefit here as well is that I can now break a build and keep people from merging in a pull request. That's a good benefit. So you'll see here, I have a pull request that should have broken for a number of reasons. And we'll get to this in a little while. This is the fun stuff, the best stuff that I'll get to later. But you can see here that this GitHub build, it broke. And right here, I have an X. I could check my details, but regardless, I'm not able to merge into a protected branch with this broken build. So I've got a number of comments around why I would not stop here. I've got a number of comments around why this is far from enough. But I want to take a quick breather, about 12, 13 minutes in, and see if there's any questions. See, small font. You can figure that out. Go ahead, if you got any questions right now, please put them into the chat. I'll give it about 30 seconds. Otherwise, we'll press forward. There's nothing else. Okay, terrific. So I blazed through that because I wanted to give everyone a level playing field as to what's been done in the past, where people typically start, and what's good but not great when doing code review. So we've created a single source of truth. We've been able to break up builds. We're starting to see some of the small stuff taken care of. But let's start with one of the obvious things, which is if I'm looking at this broken build here, right? I've got, let's see how many errors I've got. I have 67 problems here in my broken build. I don't believe, I had to actually check my commit, I didn't introduce 65 of these. I maybe have 2 new issues, but I can't really tell what I've introduced. And if I'm running in a legacy project, even the tech lead might not know what I introduced. I might have hundreds, possibly thousands of issues here. So how do you move forward in that case? How do you keep things from being too noisy, right? That's one of the biggest issues in code review is even if I'm spending the time, even if I care about my code quality, if I can't cut through the clutter and in order to understand how I can make a small difference, make a little dent in the larger problem, then I'm really just floundering. You're having trouble making an impact, and you'll probably give up. You probably just focus on building functionality, even if it's low quality. So let's see if we can do a little better. Let's also keep in mind, I'm only running a single language here. I'm only running JavaScript. So I'm only covering JavaScript. A lot of things nowadays have multiple languages in the repo. So I might have Markdown with some documentation. I might have JSON and CSS that aren't covered by a single tool. If I'm really spunky, I might have multiple languages like Python scripts. I might have Java or Go in here sitting alongside of my JavaScript. And building out that tooling and creating multiple scripts here. Let's see here. Creating multiple runs that I then need to hunt through to see, okay, what broke, what tests passed, what didn't, can get really difficult. It requires a lot of maintenance by my team. It also requires still a lot of manual hunting. I'm better, but now I've got to think about all these things. I've got to think about checking each of my scripts and sorting through all that. I'm losing time once again. So let's see how we can reduce that maintenance. How can we reduce the time needed to get higher quality code? So this is where tools like Codacy come in. Like I said, I won't name the competitors. There are a few other competitors out there, but what you're really looking for is a quality tool that can roll up all of my checks, really potentially run them for me, so I don't have to set up the infrastructure to run them. I want it to be able to either automatically pick up my configurations that I have existing, or I want it to be able to generate a new configuration for me if I don't have configurations already. These are key pieces that save time for developers and for tech leads. So let's go have a quick peek at how Codacy does it. So my repository, here, I'll hop in, and you folks are all welcome to hop into Codacy and try it out. There's a free trial, so please dig around, have fun, compare it against other things. That's what our intent is here. Is we care about high quality code, about people making people's lives easier. So please try it out. I'm going to come in here because I've got a couple of pull requests you can see. So I made on some really silly, simple features. And you'll notice right off the bat, nothing in here says 67 issues, right? I'm talking about 4 new issues and 2 fixed, 16 new issues and 2 fixed, but I'm only talking about my PRs. I'm only see the quality, the net new quality of my PR. And that's super important. I've already taken out the that weight of the other 63, the other 51 issues that I have in my main, if I come back here to the dashboard, yeah, in my main branch. So now I can say, well, I just need to go fix these issues or fix these issues, depending upon what, who I am, what I'm checking in, and what I'm trying to check against. And you'll see, we'll get to this in a moment as well. We're going to stick with linting, but we're going to come back to duplication, complexity, and coverage. So if we're just talking about linting, let's go back and look at Codacy as well and at those pull requests. Notice how I had to go into a separate tool. I had to go into Codacy to look at those things. That's a context switch. Context switches take us time. If you're already doing a code review, you really want to be doing it right in line with everything else, right? So I'm going to come in here to look at a commit, potentially merge it in and approve it. Well, let's just put the issues right in here. If I'm a tech lead or I'm a peer reviewing someone else and I come in here and I see that there's still open issues, right? Oops, Cody's found an issue, missing trailing comma, Cody's found an issue. If I see that these things are still here, I can instantly deny and say, you've got to go fix these before I'm even going to look at the deeper code, right? And now, whereas that might have taken 5-10 minutes before when I sit down for a code review with a developer, now it took me maybe 5 to 10 seconds. And in fact, if I'm just looking at this, I got a little X here, that might even be pushed into my Slack notifications. I can set this up where I don't even look at a pull request until I see it has passed. Like I don't even need to come into GitHub. So just in linting now, we've probably saved, depending on how good your team is, we've probably saved at least 15 minutes per code review every week. And if you're doing 10 to 20 PRs in a 10-person team, that starts to add up. That's hours, potentially days, just on your linting standards, just on the freedom of mind of I don't need to check these things. So we can still do better, and we will here in just a moment. But are there any questions right now about just this very first brief passover for linting, for the really small stuff and taking that off our plate? I'll give another 30 seconds.
Oh, so Dan, there's a question that came up just after the first segment. Fadi is asking, could you repeat the action purpose on GitHub again?
Absolutely. Yeah. So in GitHub, and Fadi, this is really a replacement for, if you heard of CI, continuous integration, or CD, continuous delivery, or deployment. Those are the tools that the action replaces. So like a Circle CI, like a Jenkins, actions are basically those. So in this case, I did it as a single source of truth, as a build in the cloud. The whole team says, when that passes, we're good. When it fails, we need to look at it. And so that's really, it was a step between local and like a Codacy. Built-in rules for most languages. For Codacy and for a lot of, this is for Rania. And apologies if I mispronounce anyone or don't see the name correctly based on your screen name. But yes, there are built-in rules for most languages, most tools. I'll speak from Codacy, but I believe it's going to be the same for a lot of competitors. Is we use a lot of open source tools. So ESLint, Bandit for Python, PMD for Java. A lot of those are supported by the community, and they have a lot of plugins and default rule sets. What we do is we make the integration of those much, much easier. So you're not doing that heavy lifting. You can focus on the code. So yes, there are built-in rules. Case in point for ESLint, I'm actually using the Airbnb rule set, and I made one small change. But I highly recommend starting with one of those default rule sets, no matter what language you're based in, and then tailoring it afterwards. Okay. Yeah, and actually, I will let me comment on that further one more time. ESLint's a great example because there's actually two Airbnb and Facebook both have. I believe it's Facebook. Might be Google. I always use the Airbnb standard, but these are people that work every day. Great teams, great quality, working every day in these platforms, and there's no point in really reinventing the wheel, so to speak. Why not build off of those people's work, even if it's just in quality? So taking the rule sets and then tailoring it for your team, there's no shame in that. It's not lazy, it's smart. So I highly recommend going that route. And yeah, looks like, can you customize the rules? Yep. Sami, yes, you absolutely can. And I recommend you can do it from within Codacy. We have a UI, but what I would recommend is I'd always recommend using a configuration file for your tool. Codacy will pick up on those. And that just gives you that much more flexibility to run it locally as well. It stays with the code, so your configuration sits alongside of all of your other scripts and code. So yes, you can customize, and I recommend using the built-in configuration tools for that, for your language. So I mentioned, let me look at my notes here. So we mentioned, can we do better? Absolutely, we're going to keep getting better because so far we've talked about just linting. We've taken very, very bottom level off our plate, which is good. You want to take off layers and layers and layers until you're really getting down to, if you can, just functionality and just structure. Those are the most important things for us. We want to be looking for bugs, and we want to be looking for readability, maintainability, things like that. Can I understand what the code's doing, and not necessarily some of these other smaller pieces. So let's dive in there. Can we get something that helps us with better understanding the code? Can I take something off my plate there? Well, we can. And again, this is something that shows up in Codacy and a lot of other places, is complexity, duplication, and test coverage. Complexity, and don't worry about my graph here since this is a toy example repository. My graph does not look great, but complexity, for those who aren't familiar with it, is essentially it's called cyclomatic complexity, but you can think of it as how easy it is to understand the code. In reality, it's really basing around branching. So if you've got a lot of ifs and a lot of branches within a small block of code, be it a function or an object, a module, you're going to get high complexity. And that almost always, as you get over a certain level of complexity, be it 4, 5, 6, the ability for bugs to sneak into that code just rises exponentially. If you're familiar with solid principles, single responsibility, things like that, these are all These are all goals to reduce the complexity of files and make sure that long term we're not introducing things accidentally because we didn't understand the code or because we didn't understand the ramifications of a change we're making to a branch. So I guess if anyone doesn't understand cyclomatic complexity, please go dig in. It's actually a really important concept, and it'll save you a lot of headaches long term as your code gets larger. But safe to say, this, I believe, is one of the most important issues you can check. More so than duplication. Duplication gets a lot of play. It's important, but complexity, keeping the complexity of your files down, keeping the size of your files down is something I always check. So in this case, Codacy will actually let us set thresholds. So I believe, I think it was this one. Yes. So you can see here, I've actually, if I didn't have these 16 issues, I'd actually be red on my complexity as well. As a tech lead, as a peer, I can now say, hey, I don't even need to look at your code. I know you've introduced something very complex for what we didn't think was a complex function. So either go fix that or give me an explanation as to why. And I haven't had to look through the code. I haven't had to discover it and have a meeting. The developer now knows I've got an issue to deal with, either to explain it or to go fix it. And that's probably saved 30 minutes. You think we were saving time when we were getting rid of trailing commas. Well, now I only have to have a fight about it. We've set the standards for our team. We all understand the nature of complexity, and the computer has now told us that my build has now told us that my complexity is too high. So there's no hurt feelings. There's no arguments about it. I didn't have to count the number of nested ifs in their file. I just say, it's not how we operate as a team. And that is invaluable. I haven't touched on it yet, but getting rid of those interpersonal issues in your code reviews saves, it saves tons of time, but it also saves wasted energy. It saves your relationships, which are incredibly important in a team. Like people, let them get angry at a computer. You don't want them angry at teammates, and you don't want them angry at your tech lead. So this is really, I cannot stress enough how important it is. Start getting some of these tougher things in here. Duplication, it's the same thing. I don't have a duplication example, but actually, let me double check and make sure I don't have a duplication example. Nope, I don't. But duplication, again, I can set that threshold, and here in Codacy, I'll go ahead and show how you do it, but it's gonna be different for every platform, but most will let you. I can go ahead and say that I need certain code coverage or I need certain duplication before I'll even look at your code. And now I've really put the onus back on the developer to make sure their code meets a standard before we'll talk about it. Anytime we can give people the ability to self-regulate, to self-check, and to be self-reliant in their fixes, we've saved very valuable time. People also learn faster when they are responsible for the quality of their code and for enforcing it, as opposed to someone else having to come in and double check me. And lastly, I know as a developer, I would rather have the ability to check myself before handing something in to get that essentially have a practice run before I go in front of my teammates. It gives me a higher confidence. It lowers my stress when I know I've got good stuff, and we're just going to talk about about the functionality, about how to solve the problem, as opposed to how I wrote my code. So let's check on one more thing too. This is a big one. Codacy does it. Other tools do this as well. You may need a third-party tool to do it really well, but code coverage, a lot of people don't talk about, and I don't have it set up here, but a lot of people don't talk enough about tests, about code coverage, it needs to be a first tier member of your code reviews, both what you've tested, but also making sure that you're not reducing your code coverage. All of your existing coverage needs to stay up there. So did someone break a test and then remove it? Well, one of the easiest ways to see if that happened is making sure your code coverage doesn't go down. Complexity. Sure, and I'll get to that question in just a moment. So your code coverage, what you should really be doing, in Codacy does it like this, where you run it locally or run it in a CI build and you push it into Codacy, but you really want to make sure you don't backslide. That's the most important thing. And knowing that as a developer, as a tech lead, knowing that I haven't gotten any worse is incredibly valuable. Knowing that I haven't broken anything that someone else has built, I haven't exposed us to more risk, again, lets us put that worry out of mind and focus on functionality, focus on the net new stuff. We got about 17 minutes left, if that's correct, Mercy. So I'm going to take a quick break here because I got 2 questions. And so looks like we're looking at what's an example of complexity that Codacy catches and counts. It's a great question. Let me go show you. Again, this is going to look like silly code because I have just put this in order to demonstrate squares. I think it's squares actually. So what do you see some code now? Like Visual Studio
Correct.
code. Okay, great. I'll show this quickly, and then we'll jump back to GitHub. Actually, I could have shown it in GitHub, but that's okay. So you'll see here what I've written is something very ugly, but it illustrates the point. This is the complexity that I added to this file. Something silly and pointless, but it's this nesting of your statements, and you can imagine it only gets worse as I add more else's. If I had switch statements, what have you in here, it gets harder and harder to read. And also it can create a number. If I've got multiple return statements in here, it creates this web of complexity. So that's what we're catching in Codacy. I would instantly know, okay, I saw a +5 in complexity. I broke my build. It's in this file. Actually, let me show that real quick. Okay, are you able to see a browser now?
Yes, we are.
Great, okay. Again, the small things that now I'm worried about, just like in code review. So let's see here. So I'm going to show you in, lost my train of thought. Oh, in Codacy. Yeah. So in Codacy, you can see my pull request for squares. If I come in here, I can see this complexity. I can actually look at the files. I can say, okay, where was that complexity? Okay. It was in operate. You can come in here and I can see that, it's not going to show me the complexity. It's okay, but I know it's in this file. So I know that now I can go within, this is where I really highly recommend being fully in, doing your code review. One moment while it pulls it up. So in here, I can start looking at complexity increasing per file, 5 in operate, and I can go look directly at that change. So what changed in operate? Oh, here. I see a bunch of lines here where I'm like, okay, what happened? I can now look at the file directly and start to understand, here's where I need to focus, as opposed to hunting around for it, as opposed to having to look at every file. So that's what I like in terms of complexity. There's one more question, function length. So Charles asked about, and I see there's also another question about this, but I'll take this one from Charles about complexity. Function length, Charles, typically doesn't affect your complexity. It certainly does affect your readability. But for complexity, especially cyclomatic complexity is specifically what we're talking about here. It's all about branching. So as long as it's, if it's a function that's 100 lines long, but they're all sequential, it's still gonna be complexity of one. I think one is the baseline, not zero. Because you understand I use this. Where it gets complicated is when you start reading code and going if, or else. That's when your brain should start saying, okay, we're getting complex here. I'm having to make branching decisions as opposed to just following a line by line steps. And then I see we have a question about Codacy specifically. What does Codacy offer over competitors? The big thing about Codacy that certainly I like as a developer when I'm writing code, and in my previous life before I was an engineer for Codacy, is the speed at which you can set it up. You can accomplish almost everything that Codacy does with enough time, enough resources. You could write all the integrations. I think we have one or two closed source tools, things that are proprietary. Everything else is open source. But what we do is we've done all the work to integrate, do automatic polling from your Git provider. We run all of the tools in their own containers, isolated on our hardware. So you don't have to worry about maintaining the tools or setting up the builds or anything. It just works out of the box. We also have gone ahead to put in the comments and the summaries. I'll go back to the conversation here. The summary here that we put in, things like that. The integrations with your Git providers are just there out of the gate. Could I write this? Absolutely. I could write this and have it get pushed here out of my build. Would that take you 40, 50, 100 hours? Probably would. There's no free tooling out there for stuff like this right now. So that's really what Codacy provides. And against competitors, I think, and I haven't checked their feature sets recently, but the other big player in the market, again, won't say their name, but there's another big player. They are not nearly as easy to set up. Yeah, Mercy's smiling. It's like I'll say they're out there. You guys should do your research, but I don't need to say their name. So they take a lot more time. You can get a lot of good functionality, but it's going to cost you. And if you really want to focus, if you have limited time, especially if you have limited time as a team, which almost all of us do, I want to spend as little time as possible on setting up infrastructure, hardware, and processes. I just want it to happen. So yeah. Dangerous ranges from Fadi. Oh, Fadi, that's a great question. I might need another hour. So what Fadi's asking about is, so what Fadi's asking about here with the dangerous ranges, it's really going to depend team by team. So for me, I'd say when it comes to issues, anything above 0 issues, right, is I never want to introduce linting issues into my code. I always say as a team lead, as a developer, let's keep it completely clean. There's no reason to introduce those kinds of things into our code. That just creates an ability to ignore things and get worse and worse and worse. I would have 0 tolerance for those. In terms of duplication and complexity, duplication is the hard one. It's very, I'd say every time you see duplication, you should have a conversation. Because duplication in test code isn't as bad as duplication in production code, but sometimes it makes sense. Sometimes duplication is easier to read than isolating that functionality into its own function and reusing it. But that's a team by team discussion. But every time I see duplication, I want to talk about it. Complexity is much easier. I'd say I don't like to see complexity over 4. If I'm getting complexity in the 3, 4, 5 range, I really want to think about how can I make this more understandable? How can I break it into separate functions? How can I isolate my branching so that it's more testable and more understandable So I'd say that's the easiest one. 0 for linting, and that 4 to 5 range for complexity. Okay, we got, how is Codacy different from Code Climate? So Code Climate is, I haven't used Code Climate in a long time. Code Climate is kind of a, I don't want to call it a dead product, but it's a stagnant product. So Codacy, the big things Codacy is going to do, it's going to integrate with your Git provider seamlessly. Code Climate doesn't do that. We also are going to pull your code and analyze it within a couple of clicks. You're not going to need to set up nearly as much in terms of your settings, in terms of your integrations. And then lastly, we're constantly improving. We are a continuous delivery organization. So especially in our cloud product, we're releasing features every week. Code Climate, you're not going to get that. While their goals are the same, Codacy is a very lively product as compared to Code Climate. And then I see Teddy is asking about dead code. I'm trying to think here. I don't believe we have any functionality around dead code. Dead code, you're probably talking about one of two things, which is, has that code been touched, which is unlikely. Obviously, code that hasn't been touched could still be being used. More likely, is it being executed? So Codacy doesn't have a tool for that because Codacy is doing static analysis. We don't actually compile, and we don't run against against live. We don't stand up a server and run it like through be it integration tests or real users. So we're not going to get a good indication of dead code. Code coverage could give you some of that, but unlikely. I'd say I'd go somewhere else for dead code detection. Lou is asking, is it free for private repos? It's free for personal repos. For the time being, I believe in the future, we may put a limit on the amount of time when you can use it personally, but I'm unsure of that. But as of right now, so I guess I'd encourage people to get in and try it and use it. Right now, it is absolutely free for your personal repos. Let's see. As a leader, can you help your team by asking them to add extensions? Yes. I mean, I guess, Sally, are you referring to add extensions to Codacy, or are you talking about for your team? Should you be asking them to add extensions into your products? Yeah. So this is a good indication. So Sally, yeah, you hit on the spot with something. So Codacy is really a cloud tool for protecting against the pull requests and that central source of truth. Giving them an indication locally of what might be going wrong is something that so there's not a great answer for this. What I'd recommend, let me go this route, is using Codacy as for your code reviews, using it to block, make sure you have high quality before you merge, and then making sure locally that you're using, so in this case, ESLint, use the ESLint configuration, and then use an ESLint tool in VS Code, in Eclipse, what have you, that'll give you that real-time feedback. And then if your tool versions are in sync and you're using that local, using the same configuration file, 99% of the time you should get the same results. We can't guarantee it, obviously. Different implementations of the extensions are going to be slightly different, but that's my recommendation. We do have a CLI tool that you can use with Codacy, so you can run it locally, you can run it via build server and get the exact same results as Codacy, but it still won't be integrated into your IDE. So I think there's extensions out there I'd recommend, depending on the language. That's your best bet. And Lou, yes, it does have an on-premise version. That's something we do often. Yeah, we absolutely have that, something that can integrate with your on-premise Git provider. Great. Marissa, we got a couple minutes left. I don't see any other questions. Is there anything you'd like to touch on, or anything before we wrap up here?
I think happy for you to wrap up, and then we can call it a day.
Okay, terrific. Well, I really appreciate everyone's time. I think if I had one or two takeaways here that I would encourage you to do, it's to make any small step, depending on what you've got with your team, any small step helps. Really look at where do you spend your time on code reviews, where is the value, and can you take some of that low-hanging fruit off of off the tree so you can focus on the other things. You take away the linting, make sure you're not looking at that. Can you get complexity checks? And then you can start looking at things like, can we start looking at our commit summaries and things like that. You can, with some of the extra time, you could automate the checking of, are those media standard? Are we having our PR sizes? If you want to check that, you can write a little script to do that. There's things that even beyond Codacy and other products you could start doing. But once you realize, I'm spending a lot of time looking at this, can I automate it? I highly recommend it. Because the more time you can spend focused on value and the less time you're worried in the back of your brain about missing a bug, well, the better. So I'd say, yeah, thank you so much. Last little bit, if anyone wants to reach out to me, obviously you've got my Twitter handle. You can also get a hold of me at Dan@Codacy. So pretty simple. Nice part of being a startup, dan@codacy.com. And yeah, I'd love to help you out with anything, be it quality related, be it code review related. And if you want to try Codacy, that's great too. So fabulous.
Fantastic. Thank you so much, Dan, for the insightful hour. Very informative. We appreciate your presence here and great work you're doing together with your teammates, Codacy, giving us an amazing platform. Truly appreciate it. And for all engineers who've joined, we thank you for your time. If you have any questions, you have Dan's address, you have Andela's Twitter handle. Keep the conversation going. Thank you so much. God bless.
See ya. Thank you so much, everyone. Take care.